All right, 4.7, generalized factoring, which means that pretty much all the factoring stuff we've done so far are just kind of randomly, right? So they're not going to just give you the difference of cubes kind of thing or the sum of cubes. They're just going to say, look at this and then know what to do with it. Now, if it's not cube, right, difference or sum of cubes, then the nice thing is that all the factoring can be done with greatest common factors and also factoring by grouping. But if you memorize the other stuff, it does make it go pretty good. So there we go. I don't have the sum or difference of cubes on this, but I think we will see it, and then when we do, we'll write it out when we get there. But all of these, if you can memorize all this stuff, which would, you want to do, put it somewhere where you see things all the time, like on your windshield when you're driving, so that you can, right in the middle, yeah. So don't do that, by the way. I am recording this, so that was a joke. Please don't do that thing. This is far more detailed than you'd want to. In fact, I would probably fall asleep right now if I read all this. But remember, just factoring. If you first going to want to look for factoring a greatest common factor first. Always look for that first, no matter how many terms there are. If there are two terms, then yeah, maybe some are difference of, well, I guess some are different of cubes or the difference of two squares kind of stuff. It won't always work out that way, I suppose. It actually should right now until we get a little bit more experience. But if there's three terms, you can look at factoring a perfect square trinomial. But again, factoring by grouping is always good. And then if there's four or more terms, really just four is what we should be looking at. Factoring by grouping is it's pretty convenient. Now we may see one of those examples where it's just going to have two terms, but it actually ends up being a factoring by grouping because it's already grouped for us, which is convenient. I guess that'd be a greatest common factor one. Always factor completely. So if you don't, even if you factor the greatest common factor in the beginning, always look in the end and see if one of your two binomials you can factor something out from there as well. So, and then write the complete factorization by checking. Also, you can check by going back and multiplying everything back together just to make sure you get the original expression. So, and you can pretend to have fun while you're doing it. Is there a way we can do it like a set algorithm every time? Not necessarily. I mean, the greatest common factor is, but after that, it's just kind of taking your time, like this one right here. Take your time, look at it, think about it. What are you going to do for this one? And this is one of those greatest common factor ones. So we got this x minus 2 in both. There's only two terms here. And so I'm going to pull out of that these two terms an x minus 2 factor. And then what was left over? Well, we had the 9x and the plus 3. Now it's like, wow, that was victory right there, right? But remember, always look for some kind of greatest common factor, right? And you could have done this in the beginning, which we kind of did with the x minus 2, but now within this binomial, not this one. This binomial doesn't have any common factors you can factor out except for one, of course. This binomial, though, has a factor we can factor out. From there, I will factor out a 3 because the 9 and 3 are both divisible by 3. All right, fair enough. Then what are we left with? Well, 9 divided by 3 is 3, so that's how many x's there are. 3 divided by 3 is 1, so we get 3x plus 1, and then I still have that x minus 2 binomial as well. So we end up with 3 factors in our final expression, but
I know how to.
To me, that's a nice starter, just to get us kicked off or ticked off. But on this one, so now I've got a trinomial, and the first thing, you can always stick to factoring by grouping, okay? So if you're like, you know what, I don't really care if this is a perfect square trinomial or the difference of cubes or the sum of cubes. I don't care about that stuff. I'm just going to factor by grouping. Go ahead. That would work on this one, because especially since we're starting with 3 terms. We showed how to do it with 2 terms, but usually the 0x thing usually is a little disturbing and frustrating. So on this one, you could check for perfect square trinomial stuff, but 3 is not a perfect square. 4 is, so it's like, yeah, that's cool, but 3 is not. So yeah, you should definitely look first for the greatest common factor, which there is none. 3 and 13, both of those are prime, so we can't factor one out of the other. Doesn't matter what 4, if 4 is, that 4 is divisible by 2. So what we're going to do is we're going to find the product of the leading coefficient 3, and then in this case the constant. It's just the final term. Sometimes it's coefficient. 4, 3 times 4 is 12, right? Now I need 2 factors of 12. So I'm going to split this back up. That add up to, it's negative 13 on this one, right? And that's going to allow me to split the negative 13 up into those 2 factors as 2 separate x terms. So I would start with 1 and 12. Well, that's no good. 1 plus 12 is 13. That should give us a quick hint. And just real quick, 2 and 6 isn't going to work because 2 plus 6 is 8. 3 and 4 is not going to work because 3 plus 4 is 7. Okay, now don't stop there. Don't let it just that these are all net positives stop you, because remember, you can reverse this and say, well, what if I make both of these negative? And yeah, negative 1 times negative 12 is still 12, so these 2 factors work, and if I add them, I get negative 13, right? So my negative 13x's I'm going to split up into, and it doesn't matter how you do this, but negative 1x, and I'm going to make this one negative 12x, okay? So my negative 13x, I've split up into these 2 separate terms. Then I've got my 3x squared, and then also the plus 4 to go with it, okay? And I've kind of purposely given myself a little space in between these, just so I have some space to work again. Okay, because I'm factoring by grouping, so I'm going to group the first 2, and from those, looks like I'm going to factor out an x. Okay, so from that, from the first term, the 3 stays, but only one of the x's stays, from the 2 x's there, and then from the minus 1x, you know, some students don't like to show that 1, but I like to see it now because I factored out this x, so I'm just left with the 1, so I need it. Now, as we've seen before, this means that when I factor out from my second group, I'm expecting to see a 3x minus 1. That's what I'm expecting. I don't know if it's going to be, but I feel confident that it will. So from here, looks like, so the negative 12 is our first term in this group. Right, so this group right here. So I'm going to factor out first the negative, and it looks like I can factor out a 4. So we're going to have the minus 4 there. So negative 12 divided by negative 4 would be 3. So we see it's starting to match already. 3 x's. 4 divided by negative 4 would be negative 1. So that's, if you were concerned that this was plus and how are we going to make that negative, it's because we factored out from the negative 12 and negative 4, which forced the plus 4 to become a minus. So they do match, right? So I can now factor out from both of those terms a 3x minus 1. And I am then left with what's left of the 2 terms, just like we saw in the last example, an x and a minus 4. Now, this is done, but you should check, right? 3x minus 1, I don't see any common factors I can factor out there. X minus 4, nothing common. If this was an x squared, then I'd have a difference of squares there, and I could actually factor that out more, but it's not, so that's it. 25x squared minus 30x plus 9. Guys, take a minute, try this one out. The first way that I'm going to do this, because I'm actually noticing on this one, okay? I see 25, the x squared, that's good too. And then the 9, those are perfect squares, okay? So let's look at what those are perfect squares of. So 25x squared, if I were to square that, that would have been from a 5x, because 5 squared is 25, x squared is x squared. And then 9 came from a 3, that would have been squared, right? Now, is the negative 30, is that the same as 5 times 3 times 2? I don't really care if that it's minus. That doesn't bother me at all. But yes, it is. 30 is 5 times 3 times 2, and the x. So this means that I could have just taken this, and I would have known that since it was a minus sign here, that it would have been a minus sign in my difference of squares here. Maybe I'm using the wrong terminology, but I also don't care. So it's 5x minus 3 to the power of 2, and that's pretty good, okay? Now, if you wanted to focus on factoring by grouping, you would have done it like this, myself more space. There we go. There we go. All right, so here, you look for any greatest common factors you can factor out, which there are none. So now we would take the leading coefficient 25, and in this case the constant 9, multiply these together to get 225. Now skipping a few steps, the two numbers that you would multiply together to get 225 that adds up to negative 30 would have been negative 15 and also negative 15. So our negative 30x splits up into negative 15x's and also negative 15x's. And then we have 25x squared minus 15x minus 15x, and then plus 9, and then we'd do factoring by grouping, right? Which is kind of the whole point of this, this strategy that we're doing the second time. Looks like I can factor out from that parentheses a 5x. It's better x, kind of. 25 divided by 5 is 5. X squared divided by x would just be x. And then minus 15 divided by 5 is 3. The x factored out. Now we'll factor the second group. From there I can factor out a negative 3, right? Because we want to factor out the negative because it was minus 15x. And then what's left over on the inside? Well, negative 15x divided by negative 3 would have been 5x. And 9 divided by negative 3 would have been negative 3. So you can see this is already kind of panning out the same way. You got 5x minus 3 factored out from both terms, and then you have left over a 5x minus 3. Now, some students are like, well, Sal, that's different. These are different. They're not. This is just the expanded form of this exponential form. So it is actually still the same. So this middle term right here, if you're going to use this method, should be 2 times a times b. The a I found was 5x. The b was 3, so 2 times 5x times 3 would have been negative. Again, I don't really care about the negative, actually. It would have been 30. All right, so in factoring this one, looking at all three terms, it's a trinomial. I really don't care that it's a trinomial. I mean, I do, but you can factor by grouping. So, but first, you should look for any greatest common factors. Now, I see that all these are even, which is nice. I'm talking about the coefficients. Because from those coefficients, this means that I can, right off the bat, factor out a 2, okay? But yes, then you see that all of the terms have a's as well, which means that you can also factor out an a factor as well. Okay, so what does that do? Well, the first term there, 2a cubed, we factored out the 2, and from the a cubed, we factored out one of those a, so now it's a squared. Then from positive 12, we factored out 2, so 12 divided by 2 is 6. The a squared, we factored out one of the a's, so we just have an individual a left. And then the plus 18a, 18 divided by 2 is 9. And then we factored out that individual a right there. So this is what we got. And so the 2a is factored out. That's nice. That's going to make things very convenient for us, very pretty. But we're not done. Yeah, so we got a trinomial. We should see if we can factor out in 2 separate binomials. The good news for us at this point is, I want to do it so bad. I see, well, I don't see it, but I can see it. I can put the 1 there. Okay, now the reason why I'm showing the 1 is because 1 is a perfect square. Same with the 9, perfect square, right? So I would kind of expect this to be one of those perfect square trinomials, just with addition, right? So, you know, you guys tell me though. So, yeah, so let's do it. We'll use the formula, right? So we see right here, we got this, it's 1, so you could have just taken the 1 and squared it, but also the a, right? So that's nice. And then the 9 would have been, I think we've seen that before, right? 3 squared. Okay, now let's check. So the middle term should be 2 times a times b. And yeah, there is an a. Don't get that confused. But 2 times a was 1a times 3 would have given us 6a. So it's going to work. Okay, so I can go into this and just skipping several steps with the factoring by grouping stuff. I see that I have addition between the first and second term, so it should be addition here as well. And then, yeah, I'll show it as 1a. Not to be a smart aleck, but well, kind of to be a smart aleck, but I like to see the 1 there. So, there, and then, yeah, make sure to tack on your greatest common factor. And so we use the perfect square trinomial business to get to this one fairly quickly. But again, you should get the same answer even if you do factoring by grouping. Okay, so this one, x to the power 4 minus 16. We got 2 terms. And some students may say, well, this has to be an x squared for this to work. It is an x squared that's been squared. So going back to some exponent rules, right? I'm kind of looking at our square binomial. What is the difference of squares or something like that? So from this, the minus sign is good. But what I have on this is 2 squared terms, right? So those 2 squared terms, remember, we're going to put them into 2 separate binomials with minus and plus. So what's the first term? Well, that would have been x squared. So yeah, I'm going to put an x squared into both of these binomials. And I put minus and plus. It doesn't matter if you put the plus sign in the first binomial. And then 16 would have been a 4 squared. So I've got 4 here and here. Now, this looks pretty good. And we can feel good about what we just did. But it can be factored even more. Not this one, though, because we haven't gone into addition of 2 perfect squares like this. But this is still a minus of 2 perfect squares. You got x squared and then 4, which is still a perfect square. So this x minus 4 business, okay, I'm gonna now separate that into 2 separate binomials again with subtraction and addition. But again, the x squared, that would have just, let's see if I can get enough colors. That would have been an x squared. So I got x as my first term. And then the 4 would have been a 2 squared. So I got an x minus 2 and x plus 2. And then I still have that other binomial, the x squared plus 4.
That just can't be factored out because it's a positive.
That's correct. Now it can be factored out. We just haven't gone that far in how to factor that out yet.
Okay.
But we will. But so yeah, if you're curious on how this works, it's one of those. I may be doing this wrong, so please forgive me if I am. But I believe it's. Yeah, there we go. This, and then of course you still would have had the 2 original ones.
Boy. Do I?
Yeah, that's an imaginary number, which it's not. It doesn't actually just exist in your imagination. It exists in math, which is great because it gave math people a whole new set of numbers to work with, and then they did. They were like unbelievable. We now get to do more math, and then they didn't, and that's why they did it, and they had to show everyone, and then now you are forced. Well, not now, but eventually you'll be forced to do it probably. And then you'll probably forget about it, maybe. All right, so this one. Okay, so right off the bat we see, if it's not a trinomial, by the way, so we're looking at a binomial, and that's fun. But I see the first term here, the t is cubed, power of 3. So yeah, we're looking for in this case, the difference of cubes, right? So let's look at the formula once again, because that was great. So we're looking for an a. It's minus, right? So we got minus b in the first binomial, and then everything else is plus. So that's nice too. But that was a squared plus, I think I can do better a than that. A squared plus ab plus b squared. Okay, so all I got to do is figure out what value a is and what value b is, plug them in, and then I can feel good about it.
Now, how did you know that?
All right, so yeah, what's my a value first? So again, we look here for this first term. What would have been cubed? It would have just been t right here. You could say 1t if you want. I know I did that on one of the other problems, but the a's, okay, so these a values, I'm just going to replace with a t, all of the a's. Now the second one, by the way, looks like I replaced the b with the t. I'm just kind of setting it up for the future so that the number that I'm going to be putting in there should be the coefficient. But we'll see. Okay, so there's that, and then the minus sign just tells us what operations to use. But again, what is cubed from the 1? It's 1. 1 to the power of 3. be careful. Some students like 1 times 3 is 3. Yeah, 1 times 3 is, but 1 times 1 times 1, that's 1 cubed, that's 1. So, as it turns out, right? As many times as you want. Well, B, that means is yeah, as many times. I feel like you were having a little bit of fun with that. Probably more than you should. Or not, or whatever. So that's, we gotta, and don't forget your squares at this point, right? So this is now not simplified the way that I have it. I'm talking about this one squared. Expect when you put this into the formula that it's not usually gonna be 1. Like if it was 2, you had 2 squared, you need to make that a 4, but one squared is still 1. So I kind of get away with just ending it right there. And it's good.